Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will demonstrate how to certify a multimode fiber optic link using a micro-OWL optical power meter and a WaveSource series multimode light source. There are 5 main steps in the process of certifying any fiber optic link. These steps are gathering link information and accessories, checking equipment and accessories for proper operation, entering link information into the certification tester if available, and setting an optical reference, also called zeroing, taking insertion loss measurements and storing test results, and then downloading stored test results to a PC and printing a certification test report. Before beginning any fiber test, the user must gather the necessary link information and accessories required to complete the test. Link information is used to help determine how much loss is acceptable for the fiber under test, otherwise known as a link budget. Optical loss measurements are compared to the link budget to determine if the fiber is good or not, which is the same as saying pass or fail. There are 5 key parameters that apply to any fiber optic test. First is the fiber type, which will be either single mode or multimode. In the case of multimode, this could be either 62.5 or 50 micron. Next is fiber length. It is important to know how much fiber is in the link under test in order to determine how much loss is acceptable for that particular length of fiber. Some OWL testers can be used to measure the end-to-end length of the fiber automatically, including the FiberOwl 4 bolt optical power meter. Otherwise, the user can use jacket markings, installation documents, or other length measurement methods such as OTDR. For best results, avoid estimating the fiber length whenever possible. Third is number of connections. A connection is the point where 2 fiber connectors mate together, such as in a patch panel, wall plate, or mating sleeve. Fourth is the number of splices, which can be either fusion or mechanical. For the purpose of calculating a link budget, most cabling standards do not distinguish between fusion and mechanical splices. Lastly, the user must determine what wavelengths they will test at. For multimode, this is 850 and or 1300 nanometers, and for single mode, this is 1310 and or 1550 nanometers. When using a micro-OWL or fiber-OWL optical power meter, these parameters can be entered directly into the device to calculate the link budget. However, if the link budget needs to be calculated manually, this is done simply by adding together the fiber loss, connection loss, and splice loss. Fiber loss is given in dB per kilometer and varies based on the fiber type and wavelength. To calculate fiber loss, multiply the fiber length in kilometers by the fiber loss. Connection loss is the number of connections multiplied by the dB loss per connection. Splice loss is the number of splices multiplied by the dB loss per splice. Most users will follow the fiber, connection, and splice loss specified in cabling standards, such as the TIA 568. It is also helpful to determine the connector type used in the link under test, which will help determine the right reference cable configuration to use. For accessories, it is highly recommended to keep at least 3 patch cables on hand, since there are 3 reference methods: 1 jumper, 2 jumper, and 3 jumper. Mating sleeves may also be required for some link configurations. Refer to OWL's video on reference methods for more information. Finally, if testing multimode fiber, the launch cable attached to the light source will also need to be wrapped around a mandrel according to cabling standards specifications. Refer to OWL's video on mandrels for more information. Once we've gathered all of the link information and accessories that we will need for this procedure, it's time to check this equipment to make sure that it is okay to use. Now, as you can see, we've gathered our accessories here. The first thing is our micro-OWL optical power meter, our WaveSource multimode light source. Now, a little note about the WaveSource here is that we will be using the multimode port for this procedure. Now, as you can see, there's also a single mode port here. It says SM port, but this could also be a visual fault locator, or there may not be a port here at all. To get information about what wavelengths and what type of light sources are inside your WaveSource light source, simply flip the unit over and look at the serial number label on the back. That will tell you what model number you're using. Now, as you can see, we've also have two patch cables here. We have a straight cable here that we will be using to connect the micro-owl into the link under test later on. We also have a mandrel wrapped cable that we will use for setting a reference and connecting the light source into the link under test. Now, the next thing we need to do is power on the equipment. This is simply done by pressing the on button on the micro-owl and then also the power button on the WaveSource. Now, as you can see, the WaveSource powers on to the multimode port by default. If you can see it here, the indicator LED is red. Now, what that means is that we are outputting 850 nanometers here. If the LED was green, we would be outputting 1300 nanometers. Now, on the micro-owl, you will see that there is an operating mode screen here with several different options. For the purpose of checking our equipment, we will simply use Simple Meter, since this is the easiest method to use to just do a quick check on our equipment and accessories. So since Simple Meter is already highlighted, we will press F2 to select. Now, as you can see, the reading shows under here. This is not a problem. This is normal. This is because there is no light entering the photodetector. This is because the dust cap is still on the detector port here. If we remove the dust cap here, you'll see we'll get a power reading. Now, this reading is showing us what the room light is, so it's not a correct reading as far as our measurements go. In order to do that, what we need to do is connect our patch cables in to check them out. Now, we will also remove the dust cap from the light source, and then we will connect in our straight cable here, and we'll check that one first. Now, as far as the target power levels go, what we're looking for is a value of about minus 20 dBm. Now, minus 20 is where we calibrate our multimode light sources at. Now, that calibration also includes a mandrel wrap. As you'll see, this power level here is a little bit above minus 20, which is a perfectly fine. As long as you're close to minus 20, the cable is okay to use. Now, the reason that this power level is a little bit higher than our reference or our calibration level is because this is a straight cable. It's not wrapped around a mandrel. But what we've proven here is that this cable is okay to use, so we can disconnect it from the testers, put the dust caps back on, set it aside, and then we will check the mandrel wrapped cable. Okay, we'll connect it in exactly the same way. Okay, and as you can see, we have a value that's very close to minus 20, which is the calibration level of our light sources. So what we've done so far is proven that the equipment is in proper calibration, and the patch cables that we will be using for the test are sufficient for use. The next step that we will need to do is set up the meter for the certification test and zero out the equipment. Now that we've verified that our equipment and accessories are in proper operation, we can start the process of setting the meter up for the certification test. Now, if you remember from before, we were in Simple Meter. Now, Simple Meter is not to be used for the link parameter setup. We need to be in certify link mode for that. If you remember the certify link mode from the operating mode screen before. So to return to the operating mode screen, we simply press the done key on the micro-owl to return to operating mode. Then we press F1 to move down to highlight certify link, and then we'll press F2 to select. Now, the start menu shows you a couple different options. The option for setting up the meter to do a test is called Link Wizard. Link Wizard is simply the process by which we're entering our link information. So to start the process, we press 1. And then for this particular part of the procedure, we will not need the light source. So I'm going to set that aside for now so I can zoom in on the micro-owl display so it's easier to see. Okay, now you see the screen here. It says select link. Now, as far as the micro-owl is concerned, when you see the word link, that simply means a group of fibers that have identical characteristics. So the same fiber type, same fiber length, same number of connections, and same number of splices. Now, the fiber link number 1 here is a place to store one set of characteristics. As you can see, there are other fiber links here. In fact, there are 8 different sets of link parameters that you can store. What we're going to do is we're just going to select fiber link 1 for our purpose here. And as you can see, there's an asterisk here, and then we have a fiber link 1 highlighted. So once we see the fiber link 1 highlighted, we can press F2 to select. Now the link name here can be changed. It can be changed to the job name. You can be changed to the customer you're doing a job for. Whatever you want to do to make the report more meaningful. However, what we're going to do is we're just going to leave it at fiber link 1 for our purpose today. So when you're done entering information in an entry screen like this, simply press the Done key. Okay, now we see that we can enter the date of test. Now this is helpful to be able to enter the date of test in case you're setting up the meter today for a test you're doing tomorrow, for example. What we need to do to enter the date is we need to backspace using the F1 key all the way to the beginning. And as you can see, the format for the date here is a 2-digit month, 2-digit day, and 2-digit year with separators in between. So what we're going to do is we're going to enter in the date. And to enter a special character, we simply press and hold the 0 key to scroll through the list of special characters. And for our purpose, we can use a dash here. It works just as well as a slash. Okay, now that we've entered the date, we can press Done. And we come up to a screen that says Fiber Standards. Now, the default value here is TIA 568. This is the standard that most people will use in the United States, at least. There are other standards, such as the ISO standard you see here, which is used a lot in Europe. There are some Ethernet standards, including 10 gig Ethernet. There are also some user-definable standards in case you are an advanced user and you want to set up your own TIA-type generic link budget. However, for our purpose today, we're just simply going to choose the default value, and since it's already highlighted, we're going to press F2 for select. Okay, now we see a screen that gives us an option of fiber types. Now these are the 4 fiber types that are supported by the TIA standard. Now since we're doing a multimode test today, what we'll do is we'll assume that we're going to use 62.5 micron multimode fiber. Now let's assume that's the fiber type in the link we're testing. If our link was 50 micron, we would use the 50 micron option. So F2 to select 62.5. As you can see here, we're asked to enter the length of the fiber link under test. Now this is something that we need to know because we need to know how much loss we are allowed to have for the particular length of glass that we're using. Now you can see that the entry field is blank, so it's ready for us to enter the length. But as you can see over here, it says feet. Now this means that we will be entering the length in feet. However, if you want to change this to meters, you can enter the length in either meters or feet. So by pressing F2, this will toggle this value here, as you can see. Let's just assume we're going to enter in feet. Most jacket markings are shown in feet anyway. Let's assume our link is 325 feet. So we're just going to press 3, 2, 5. And then when we're done, we simply press the Done key. Now, we are asked to enter the number of connections in the link under test. Now, a connection is simply a patch panel, or it could be a wall plate or another mating sleeve. What we have to do is we have to count how many of these connections are in our link. Typically, this will be 2 because you'll have a patch panel at either end of the link. So let's assume that we're testing a typical link. We'll press 2 and then hit Done. Lastly, it's going to ask us how many splices are in the link under test. Now, for the purpose of this entering this information, most cabling standards don't distinguish between fusion or mechanical splices. Now, usually multimode links do not have splices in them. It should be noted that if if you terminated the cables with Unicam or some other no polish, no epoxy type connector, there is a little mechanical splice inside the ferrule of those connectors. So you would not be incorrect to add each one of those connectors as a splice. So let's just assume that we are doing that with the Unicam connector. We'll press 2 here, and then we hit done. Okay, now you see we have a review of the information that we've entered earlier. The standard, we see that we have 100 meters. The reason it says meters here is because fiber optics wants to be in the metric system, and the micro-owls converted 325 feet into meters. It also shows that we've entered 2 connections, 2 splices, and 62.5 micron multimode fiber. This is correct, so we're just going to press F1 to confirm. Okay, now this screen, this is the next step that we need to do. It's called set references. It's also called zeroing. This is where the light source will come into play. So what we're going to do is we're going to zoom back out a little bit so we can get both of the units in the screen here. Now, as you can see, there are 2 different wavelengths here, 850 and 1300. Those are the 2 multimode wavelengths supported by the cabling standard. On the left-hand side, you can see an asterisk. That's simply denotes which wavelength is currently selected. And then over on the right-hand side here, you see the reference level in dBm. Now you can see it says not set. It's because we haven't set the references yet. Now, in order to set the references, we will press the F2 key here to start the set reference procedure. But what we want to do first, let's go in order here and start with the 850 nanometer wavelength. So once we have our wavelength selected, we press F2 to begin the set reference procedure. And now the meter is going to ask us to connect our 850 nanometer source to our meter. So as you can see, the patch cable is already attached. The multimode port is active, and it says 850 nanometers. So we are connected the way we need to be. So once we've verified that, we simply press F1 to confirm. And then just a fail-safe asks us to reconfirm. Just make sure that we've actually got everything connected right. Press F1 to confirm and save the reference. Now, as you can see, it says minus 20.54. This is an okay value. Remember, we don't want to exceed minus 21. So now we're assuming we want to test 2 wavelengths, so we have to set a reference for 1300 as well. So we press F1 to move down to the 1300 wavelength. We press the lambda key to switch to 1300 nanometers. As you can see, the indicator LED is now green. And we just press F2 to begin the set reference procedure. And we'll press F1 a couple times to confirm. And as you can see, now our 1300 reference is minus 20.33. This is still okay. So what we've done is we've set our references, and we are actually done setting our references, inputting all of our link information. One helpful tip is to check your patch cable before you begin to make sure that you actually have zeroed and nothing else is going on. So in order to exit the set references screen, simply press the done key, or you can press F3 for done here. And it'll say begin taking readings for our fiber link number. So you press yes to confirm that. Now, as you can see, we see a reading up here. Doesn't look right. We're supposed to have zeroed our equipment. Now, the reason this reading is incorrect is because our wavelengths are not matching. As you can see, it says 850 nanometers here, but our light source is set to 1300. So what we need to do is we need to set our wavelength to 850 nanometers. Okay, as you can see, it flashes briefly and then goes solid. Now, look, as you can see here, we're still very close to zeroing. What this means is that we have zeroed out our equipment. Now, it's also helpful to check both wavelengths. So I would like to take this opportunity to demonstrate a feature that is very helpful when using the WaveSource series light sources, and that's called auto mode. Auto mode allows you to test 2 different wavelengths at one time. So it alleviates a lot of confusion and is a tremendous time saver. So to enter auto mode, in fact, both units need to be in auto mode. Now on the micro owl, to enter auto mode, simply press the 1 key, A for auto. So press 1, you'll see it says auto on, and then you'll see that down here where it says wavelength, it's toggling between the current wavelength and auto. Now when it's toggling this way, it means that the micro owl is waiting for an auto testing signal from the light source. Okay, as you can see, this F2 option here is blank. This is actually where the store button would appear. Now the reason it's blank is because it's expecting to see 2 wavelengths and it's not getting 2 wavelengths. Once we get 2 wavelengths, you'll see that this store button appears. Now on the other side, to set into auto mode, this is a little tricky. It might take a couple of times for practice, but what you need to do is press and hold this lambda/auto button until you see the indicator LED begin to flash, and then immediately remove your finger. So I'm going to demonstrate that now. Okay, as you can see, it took me a couple tries here. But now, once you know you'll be in auto mode when you see that this indicator LED is alternating between different colors and between flashing and solid. And over here on this on the micro owl screen, you'll see that both wavelengths show up. You see that you're very close to 0 on both sides, or both wavelengths. So what this means is that you set a reference for both wavelengths. You've set the meter and source into auto mode, and now what I'd like to do is kind of explain a little bit about what you're seeing on the screen here. As you can see over on the left-hand side, you have your pass or fail rating, your wavelengths. And you see there's 2 different sets of data there. This big number and big numbers in the middle are your loss reading. Loss is given in dB. If you see HZ show up, that's when this flashing signal, the auto testing signal, is coming in. 73 degrees, that's temperature. Percentage is battery life. You'll see over here, fiber link 1, that's our link name. And then you'll see new name here. New name means that we haven't stored any data, so we haven't had an opportunity to name the fibers yet. And then again, over here, you see your wavelength, the currently wavelengths that's currently being tested. And then again, the bottom menu of function options here. So once we've verified that we've set up our equipment, we've verified that everything is zeroed out correctly, it's time to take readings. Okay, now that we've zeroed out all our equipment, we've set it up for the test that we're going to be doing today, it's time to take readings. Now, in order to take readings, we simply need to take the light source to one side of the link under test. As you can see here, we'll do that. And we can disconnect from the power meter to do so. Now, I'd also like to take the opportunity to explain a couple things about what you don't want to do here. The first thing is you do not want to disconnect the connection here. What this does is, if you disconnect and reconnect, you're not assured of getting the same reference level again. So if you do disconnect, you'll have to re-zero. You have to start all over again. The second thing, and this is specifically related to multimode fibers, is that you don't want to let the cable unwrap from this mandrel. That also changes your reference level, and if something happens to this this mandrel, you will also have to start over again from the beginning. So it's really important to not disturb the mandrel and not disturb this connection here. Now, taking the patch cable we set aside earlier with the micro owl here to the other end of the link, we are ready to connect into the link under test. Now, for convenience sake, I have this little box here. It's simulating a fiber link. Now, there's a coil of fiber in here that we will use to pretend that it's the link between 2 closets. Let's say side A is one closet and side B is another closet, and these are 2 different rooms. So now that we have our equipment on opposite ends of the link, here, let me zoom out a little bit more here so I can see better. We can take our patch cables and plug them in to port number 1. Obviously we want to start out at the beginning. Port number 1 is the best place to start. So we take our patch cables here and we connect in to fiber number 1. Okay, now it'll take a few seconds for the micro owl to acquire an auto testing signal, but once it does, you will see that there are 2 wavelengths on the screen here. You'll also notice that the store button, it has reappeared. That's because the micro owl has enough information to store a dual wavelength test. Once we're ready to store that reading, we simply press F2. And because this is the first fiber test that we're doing for this job, we're asked to enter a label. Now this label is simply a prefix that describes the fiber length that you're testing today. It's just another way of naming it. The micro owl will automatically put a port number after this label. So the number 1, for example, will be the first port number that will be saved. So it'll put a number 1 after it. So once we're done entering this label, we simply press the done key. And you'll see that we have our readings on the screen here. We have our link name, we have our fiber name, and we have our wavelengths, dB loss, and our pass-fail results. So if we're satisfied with this particular test result, we can press F3 for save. Now, as you can see, the number has auto-incremented here to the number 2. This means that we're going to be storing, or we're going to connect into fiber number 2 and store that reading. But what I'm going to do here is I'm going to speed up this process a little bit. And finally, we store a reading for fiber number 6. Okay, now as you can see, all of those readings passed, so we have a good link. All the fibers are good, they all pass. So once we're done testing all of these fibers, we're satisfied with the results. We can take the micro owl to a PC and download the test results into a certification report. Once data has been stored in the optical power meter, test results can be downloaded to a PC to produce a certification test report. First, install the USB driver and Owl Reporter software from the supplied CD or a USB flash drive. Connect the power meter to the PC using the supplied USB cable. And then power on the power meter. Then start the Owl Reporter program. The program shortcut can be found in the Start menu. When the software has started, the screen will initially say no data loaded as shown here. Download the test results to the PC by pressing either the download menu option or the download button. While downloading, the status bar will say searching for Owl device. Once the test results have successfully been downloaded, the data will appear in the Owl Reporter screen. The test results can be viewed in 2 different formats. This view is called Circuit Detail View. It shows detailed information about a single fiber run. The other view is called Circuit Summary View. Circuit Summary View shows basic information about a group of related fiber runs. Certain buttons become active when Summary View is selected. Pass-fail, overhead, which shows how close the test is to its fail point, or optical loss. Toggle between Summary and Detail View by pressing this arrow button. Test results can be printed from the File menu or Printer button. The printout will show test results based on the currently selected view. The reports are formatted to look like the Owl Reporter screen. This has been another instructional video from Owl, the wise choice in fiber optic test equipment. For more information about additional instructional videos, or Owl fiber optic test equipment in general, please visit Owl's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.